Lesson 23, talking about ellipses one more time. Now, the most unfortunate part about this entire section, maybe not for you guys, but for me, is that there's no real information here. What I mean by that is these are all formulas. If you can memorize the formulas and where all the information is, then you don't really have to know or understand any of it. It's just a matter of saying, hey, an ellipse has this equation and all this information is true. In terms of parabolas, the same statement can be said. If I have a parabola, then this is the equation and all this information is true. It's honestly just filling in the correct pieces. So, let's talk about question 8, or example 8 in your notes. Again, we're backtracking to before h comma k so that we can talk about all of this information. So, I have this equation, and I should actually just redraw that here. X squared over 25 plus y squared over 49 is equal to 1. Now, what we're going to do when we're trying to plot this or graph it or find all the information of it, now the question specifically says find the vertices and the foci. What I'm going to do is I'm going to find those pieces of information. I'm also going to graph it and find the major and the minor axes. Now, the reason why I'm going to do all this is because it'll help us put all this information together. Now, the way that I'm going to do this is by changing this equation so that I see it as what it really should be in terms of the formula. X squared over a squared plus y squared over b squared is equal to 1, where I have subtractions if I need it. Notice the center is still at 0, 0. I'm going to go ahead and write that down too, might as well. Okay, there's no addition in terms of x, there's no addition in terms of y, so the center's at 0, 0. Now, in which direction, the x-axis or the y-axis, is my major axes? Where are the vertices and the foci going to lie? Notice the value for that is underneath the y. That means my major axis is going to land in terms of the y. So if I were to try and plot this in some way, I would have it looking something like this. Okay, it'd be exaggerated in the y direction as opposed to the x direction. Now, where are my vertices? My vertices are supposed to be at the end of the major axes. What's the length of the major axes? Well, remember, it's 2 times the a value, 7. So that's 14. That's my length of my major. The length of the minor is actually going to be 2 times the 5. Again, having these numbers in terms of what are they in terms of something squared gives me all the information I need. That's going to be 10 then. Now, where are the vertices? Well, since we're centered at the origin, the vertices, okay, are a length of 7 up this way and 7 down this way. Well, then that means that this point would actually be 0, because I'm not changing in terms of x, comma, 7. And this one down here would be 0, comma, negative 7. That's it. That's my vertices. I'm going to go ahead and plot those over here so we have them all together, 0, comma, 7. The last thing I need to work with is the foci. Now, the foci actually require me to do some extra work here. Remember, I have to have that other formula. C squared is equal to a squared plus, sorry, not plus, minus b squared. I have a plus sign over here. There should be a minus sign here. Again, that's just a nice little way to remember it. If I have the plus sign here, I should have a minus sign here. This will change when I look at it later, when I look at a hyperbola later. So, what's my a value again? Well, the a value is 7. So, really, a squared is 49. Minus, what's my b squared? Well, that's the 25, because my b value is 5. So this is 49 minus 25, and that should be equal to c squared. Well, if I do this math correctly, so I don't make any mistakes, I get, what is that, 24? Let me check it one more time. Yep, 24. So I have c squared is equal to 24. That means my c is equal to the square root of 24. Where are my foci? Well, my foci should be vertically up and down from the center between the vertice and the center. So it should be here. Well, the square root of 24, if I do that correctly, well, let's see here. It'd be between 4 squared is 16, 5 squared is 25. It would be between 4 and 5, which is between 0 or 7 and 0. So this does make sense for us to have this point between those two. That's a way to check it to make sure I didn't make any mistakes. Okay, if I made a mistake mathematically up here, I'd get, like, say, the square root of 50 something. It'd be something greater than 7. The vertices would be up here, and it wouldn't make any sense because it's supposed to curve around the vertices, in towards the vertices. Oh, sorry, the vertice points are supposed to curve around it in towards the foci points. So this here is the change for the foci from the center. So the center to that point is going to be 0 because I'm not changing in terms of x, and adding root 24 in terms of y. That foci here is going to be 0, comma, negative root 24. So therefore, I'm going to write those over here. 0, comma, root 24, and 0, comma, negative root 24. And if I zoom this out just a little bit, you will see all of the information all at once for these ellipses. This is the original equation. I changed it to this so I could see my B value and my A value. We are always going to set it up so my A value is greater than my B value, and then it follows the rules of I'm going to add that value, I'm going to add that A value to get my vertices in terms of my y-axis if it's under y's, and my x if it's in terms of the under x's. My foci are going to be based on this formula, c squared is equal to a squared minus b squared, and I'm just going to use those two original values that I was given. I'm going to plug that in, I'm going to find out what c is, and I'm going to use that c value to find out where my foci are. My major, minor, and the center are all given to me basically right by the graph. So that covers doing an ellipse centered at the origin. What if I was looking at an ellipse not centered at the origin? And the equation of that would look something like this. 4x squared plus 9y squared minus 8x plus 36y plus 4 equals 0. And you're thinking, Mr. Eckerd, no, that's not the equation of ellipse. I don't see the x minus something divided by something squared and the y minus something divided by something squared, and it all equals to 1. Well, yeah, you don't see it because recall in the last video, completing the square is something that comes back a lot, and I can just hear you guys moaning. I just know you guys are like, you got to be kidding me, because notice I have 8x and a 36y. I have to complete the square twice. Okay, I have to complete it on the x's, so I'm going to put all my x's together first, and then I'm going to put all my y's together, and I'm going to go ahead and get this all added together and move the constant over. Now, I need to complete the square on this information right here, this thing right here. For me to be able to do that, I actually have to divide this whole thing by 4 and factor that 4 out. So I'm going to have x squared minus 2x plus some number that I don't know what it is to complete the square on this. Plus, I'm going to do the same thing with this. I'm going to factor out the 9 from both those pieces. I'm sorry, this is y squared and this is y. So I'm going to factor out the 9 and get y squared plus, if I factor out 9 from this, I get 4y. I should add another piece. I'm going to go ahead and make this a pentagon. So I know I'm adding something here, and they're not necessarily the same numbers. Now, I still have this equals to a negative 4, and on this side I'm going to add some sort of square multiplied by 4. If I were to distribute this back through, that square would be multiplied by 4. So I have 4 times that square, whatever that square number is. And then again, the 9 factored back through would be 9 times that pentagon. So I have to do 9 times that particular value. And I'm running out of space here, so I keep having to zoom out. So let's complete the square on both these situations. In terms of this one over here, remember, I take the value out here, I divide it by 2, and I square it. What value is that going to be? It's going to be a value of 1, negatively. So it's positive 1 when I square it. But on the inside, I'm going to have this is equal to a negative 1 squared. So when I actually factor this thing right here, I'm going to have 4 times x minus 1 squared. Again, that negative 1 right here, that negative 1 right here will be coming from this negative 1 right here. Now, if I'm going and adding 1 on the inside of here, I'm actually adding 4 on the other side, so I just fill in this box over here with a 1, and it will be adding a 4. Here, I'm going to do the same thing, 4 divided by 2 and squared. Again, that middle term there. That's going to give me 2 squared, so that's going to be 4. I'm going to put a 4 here and over here. So, moving back over here, what does this thing factor into? Well, it's going to be 4x minus 1 squared plus 9 times, this whole thing is supposed to factor into y plus the 2 squared. This is equal to a negative 4 plus the 4 plus this 9 times 4, which is 36. Given I have all of this, I'm going to zoom out one more time. This is really canceling each other out. I'm left with just 36 here. So I'm going to rewrite this up at the top. I'm going to have 4 times x minus 1 squared plus 9 times y plus 2 squared is equal to a 36. Now, remember, the equation of an ellipse has to have it all equal to 1. So the last thing I need to do is divide both sides by 36. Divide both sides by 36, because I want this side to be a 1. Now that side's a 1. If I distribute my division to both pieces, what's 4 divided by 36? Well, that's just going to be a 9. So it's x minus 1 squared divided by a 9 left over. Again, 4 on top, 36 on the bottom. It'd be 4 over 36, which is just going to be 9. Plus, now if I do 9 over 36, that's going to be a 4 left on the bottom. So now I have this equation right here, which is in the generic form of an ellipse. Okay, let me very quickly go through all of the details on that. So I'm going to redraw it over here so I have it. X minus 1 squared divided by 9. Let's make it 3 squared on the bottom. Plus a y plus 2 to the power of 2 divided by, I'm going to change that 4 to a 2 squared on the bottom, is equal to 1. Now, this is going to go very quickly because these are legitimately just formulas. I'm going to start with the major and minor axes. Okay, the major and minor axes. The major axis is going to be 2 times 3, the larger value on the bottom, so that's 6. The minor axis is going to be 2 times 2, 2 times this value on the bottom, so that's 4. Next thing I'm going to talk about is the center. The center is going to be at a value of 1, comma, negative 2. I now need to find out what my foci are, and actually, again, this says find the center of the vertices, the foci. I'm going to go ahead and do the major and minor just so that I have it if they ask. I need the foci, and I also need the vertices. Now, the vertices I should have written first because they're easier to find. Notice the larger value is under the x, so my vertices are going to be changing in terms of the x coordinate. So, if I were to plot this thing, I'm going to do that very carefully if I can here. My center's at 1, negative 2, 1, 2. So there's my center. The majority change, and actually, watch this happen. 1, 2, 3. There's the vertice. 3 units in the x direction. 3 units in the x direction. 1, 2, 3. There's my other vertice. 3 units in the x direction in the opposite way. How's my y going to differ? I'm going to go up 1, 2 units. 2 units. I'm going to go down 1, 2 units. 2 units. This is going to be a little bit off, but is the ellipse that I'm playing with. Again, 3 unit changes from the center in the x direction, 2 unit changes in the y direction from the center. So, where are my foci? Well, it should be an x value of 1 plus 3 more. X value of 1 from the center plus the 3 more. So it's actually going to be a 4 comma negative 2. And I'm going to do the same thing, but I'm going to go 1 and I'm going to subtract 3. So it's actually going to be 1 minus 3, which is a negative 2 comma 2. Sorry, negative 2. Lastly, this is for my vertices. I told you I should have written those first. The last thing we need to work on is the foci. Well, with the foci, we need to follow that formula again. A squared, again, minus b squared is supposed to be equal to c squared. So really what I'm going to have here is c squared is equal to the larger number, 9. 3 squared is 9. Minus the smaller number, b squared, which is 4. This is going to be 5. So I have c is equal to the square root of 5. Why is this not plus or minus? Well, because the foci, it won't really matter. The foci, there's going to be 2 of them, one in here and one in here. And it's going to be from the center in terms of an x change. So 1 plus square root of 5 comma negative 2, and 1 minus the square root of 5, negative 2. Those are all of the information for these ellipses. Be very careful when you're doing them. It's a lot of information, but it's honestly just memorizing what we're playing with.